Good morning everyone. So today I am going to discuss with you the numerical of Graham's diffusion law. Graham's diffusion law. As Graham diffusion law I have already discussed in my previous class. So today we are going to discuss the numericals one. And what was the relation in Graham's diffusion law is R1 upon R2 is equal to root M2 divided by M1. Okay, this was the relation between rate of diffusion of gas 1, rate of diffusion of gas 2 with the molecular mass of gas 2 and molecular mass of gas 1. So this was the relation, one relation. Another relation was R1 upon R2 is equal to root D2 upon D1. And third relation is R1 upon R2 is equal to V1 by T1 into T2 by V2. These were the three relations that I have discussed in the previous class. Okay, now what our question is asking to us: an unknown gas diffuses 4 times as quickly as oxygen. Calculate the molar mass of the gas. So if I'll take unknown gas X, okay, and the second gas is oxygen, O2. Okay, so diffuses 4 times means rate of diffusion of gas first means unknown gas is R1 4 times as quickly as oxygen. So 4 of R. Let us suppose the rate of diffusion of oxygen is R, then the rate of diffusion for unknown gas is 4R because it is as quickly as oxygen, 4 times as quickly as oxygen. So second oxygen molar mass is 32 gram per mole. Okay, you can write the unit. I have already discussed that you need to put the unit. Now R1 divided by R2 is equal to M2 divided by M1. If I am taking R1 an unknown gas, so 4R is the diffusion of first gas means unknown gas, and the R is the diffusion of O2. Then M2 is 32 means the molar mass of oxygen is 32, and M1 means for the unknown gas we need to calculate. Okay, so with R is cancelled out, and 16 is equal to 32 by M is equal to 32 divided by 16. The molar mass of the unknown gas is computed as 2 gram per mole, or we can say 2U2. Okay, 2 AMU. That depends upon the unit that we have taken. I have taken here gram per mole, and so I have calculated the molar mass of unknown gas as 2 gram per mole. So now I am going to discuss the kinetic molecular theory of gas. The main thing of this theory is the postulates of it. Postulates of kinetic molecular theory of gases. The first postulate of kinetic molecular theory of gases is all gases are made up of extremely small identical particles. Means the gas particles are so small in nature that you can't see them, and they are very large in number. There is no attractive forces between the gas particles. Gas particles. Okay, there is no attractive forces between gas particles. And the third is there is a large distance between the gas molecules that we can say the volume of gas is almost negligible as compared volume of the molecule is almost negligible than volume of the gas. The pressure exerted by gas is the striking of the molecules with the walls of the container. Fifth, the average kinetic energy of the gas is directly proportional to temperature. Means if we are going to increase the temperature, the gas molecules got the kinetic energy in them, and if the kinetic energy is high, then the average kinetic energy is also high. So after that, molecular collision are perfectly elastic. That there is no loss of energy when one molecules collide with each other. See, I have these postulates, 6 postulates. Molecules, small identical particles, means molecules are too small that we cannot see them. And they are very large in number. There is no attractive forces because molecules are at a very large distance. If the molecules are at very large distance, then we can't say that they are going to cover the actual volume. Means we can't see them, and we can't say that they are occupying some volume in the whole gas. The pressure exerted by the gas pressure is like the walls, means pressure is force upon area. So the gas molecules strike at this area with the force, strike at this area with the force, so they are going to give us the pressure of the gas. Average kinetic energy is directly proportional to temperature. And then molecular collision are perfectly elastic, then there is no loss of energy when one molecule collide with each other. Means molecular collision is almost perfectly elastic, and so there is no loss of energy. One molecule collide with other, it is giving his energy to this molecule, and after that it is giving its energy to other molecule. So this is almost perfectly elastic one. Okay, so this is kinetic gas theory, means the postulates of kinetic gas theory. Now what is kinetic gas equation? So kinetic gas equation is PV is equal to 1/3 mn u square. Okay, and where n is the number of molecules, in volume V, m is the mass of molecule, and u is the velocity of the molecules. Okay, so what is kinetic energy? Is half mv square or half mu square. Here I am taking u bar as a root mean square velocity. Okay, so if I am calculating kinetic energy for n molecule, so I can write ek is equal to 1 by 2 m n u square. Okay, so this is the answer. If I can write in the PV is 1 by 3 mn u bar square. I can multiply with 2 and divide it by 2. Okay, mn u bar square. This is first equation, this is second equation. Can I put first equation in the second equation? Right, because it is also 1 by 2 mn u square. It is also 1 by 2 mn u square. So PV is equal to 2 by 3 ek. Okay, this is the relation between PV is equal between pressure, volume and kinetic energy. Or what is ideal gas equation? PV is equal to nRT. If I am taking it for 1 mole of gas, then RT is equal to 2 by 3 EK, or EK is equal to 3 by 2 RT. This was for n moles of gas, 3 by 2 nRT, and for one molecule, how we can calculate the number of moles for one molecule? N is equal to number of molecules divided by Avogadro number. So I am taking one molecule, so 3 by 2 into 1 by Avogadro number into R into T. Okay, so I have this 3 by 2 R T divided by Na. This is average kinetic energy for one molecule. So R by Na is equal to Kb. This is Boltzmann constant. R by Na you can say is equal to Kb. So 3 by 2 Kb into T. What is the value of R? R is universal gas constant. R value is 8.314 joule per Kelvin per mole. So 8.314 joule per Kelvin per mole is divided by 6.022 to 10 raised to power 23 mole inverse Kb is equal to Kb. Kb we are going to calculate and we will get 1.38 into 10 raised to power minus 23 joule per Kelvin. This is the unit for Kb, means Boltzmann constant, and remember it. So this is Kb. As I told you, kinetic energy is directly proportional to temperature. Kinetic energy is also directly proportional to U square. So U square is directly proportional to T. Means as the temperature increases, velocity also increases. U is directly proportional to root T. So this is all about our today's lecture. Okay, if there is any doubt, then you can ask me. One thing also, temperature. If temperature increases, means thermal motion increases. Thermal motion means motion due to increase in temperature. Thank you so much for watching.